Hello and welcome. Thank you for joining us. This is Sharif from Qualcomm. I'm responsible for product marketing for Snapdragon LTE and 5G modems. And today's a very exciting day because the Samsung Galaxy S8 and S8 Plus were announced. These phones have the Qualcomm Snapdragon 835 mobile platform inside, which also includes the Snapdragon X16 LTE modem. The first Gigabit LTE modem in the world. So it's obviously very exciting that we are finally seeing this technology, which we've been talking about for about a year now, finally make it into devices. And what I wanted to show you here was essentially, there's a question that we get often, and that is, okay, Gigabit LTE as technology is great in terms of the peak speeds. So I'm not sure if you've seen the tweet by Neville Ray showing the peak speeds that the Galaxy S8 is able to achieve in the lab environment, and the peak is around 979 megabits per second. So of course that's great, but you're never going to see that in real life. So what kind of speeds can you expect in real life? And so to answer that question, we actually conducted this pretty massive network simulation. It simulates a Gigabit LTE network actually on T-Mobile spectrum. So Band 2, Band 66, and Band 66. And there's a mix of devices in the network. So what you see here is that there's 10 cell towers, basically, and every cell tower has 3 sectors. And the colored dots are the users. Now, not every user has a Gigabit LTE device, which is why you actually see that they have different colors. So, in this particular scenario, 40% of the users have a Cat4 phone, which is the most basic LTE capability that you can get. 26% have Cat6, and so on and so forth, until only 7% of the users in the network have Gigabit LTE devices. Okay, so and of course, everybody is generating traffic. So some people are browsing the web, some people are streaming video, some people are downloading files, and our simulator actually is able to simulate the real network and how it schedules people, so that the tower's spectrum resources are shared. So what we can do is, in addition to, for example, selecting any individual user and you can get what kind of speed they're getting, we can actually compare kind of the speeds overall for devices of different LTE capabilities. So I'm going to go into comparison mode here, and we always, to keep things fair, we compare people in the same cell sector. So I'll select this one sector here, and let me select let's see, there's different types of traffic that we can look at. So like I said, there's some people that are just doing web browsing, some people that are streaming video, some people that are downloading files, and then Poisson type traffic is bursty traffic. So that's, you're scrolling through your Twitter feed or Facebook news feed, and your phone is constantly hitting the network. So let's look at the FTP traffic type. So somebody downloading a file from, Dropbox or Google Drive or something. Okay. For condition, let's look at the 50th percentile. So somebody who's not in, super close to the tower, and not somebody who's very, very far from the tower, but just kind of the median users. And then let's compare Cat6 and Cat16. And the reason why I'm going to do that is I would say Cat6 LTE is kind of the most common device capability in a lot of devices today. And of course, Cat16 is Gigabit LTE. So the Galaxy S8 and the S8 Plus, for example, are Category 16 devices. So let's compare Cat6 and Cat16. Okay, so we're going to start to see some data. Let me bring up a few graphs that will illustrate things a little bit better. Okay, so what this is showing us is that the median Cat16 user is getting real-world speeds of around 93 megabits per second, whereas the median Cat6 user is getting 52 megabits per second, almost 53 megabits. So the Cat16 user is not getting 1 gigabit per second, obviously, because again, this is the real environment, so there's interference, there's noise from all sorts of different sources, and of course the network is shared between multiple users at the same time. However, there is in fact a relationship between the improvements of the theoretical capabilities of the handset and the real world speeds that you will see. So here it's almost double basically between Cat6 and Cat16. But actually the graphs on the right show probably a more interesting story. It's not just that the median Cat16 device is getting faster speeds than the median Cat6 device, but look at the network resources that the Cat16 device is using. So this is actually the physical resource blocks. So you think of the spectrum that the network is making available to the users. It actually divides it up into chunks called resource blocks, and then it allocates those chunks to the different users. So the Cat16 device, the Gigabit LTE device, is actually using fewer resources than the Cat6 device to get the faster speeds. And the reason for this is because we're using technologies like 4x4 MIMO, because we're using technologies like 256 QAM, whereby we're cramming more bits into every LTE transmission, we actually get more bits over the air in a smaller amount of spectrum. And you can see that right here. So this is showing that for the Gigabit LTE device, the network is sending 4 bits per second on every 1 hertz of spectrum that's allocated to the Gigabit LTE device, whereas the Cat6 device is only getting 3 bits per second for every 1 hertz of spectrum that's allocated to it. And you can actually see that as well. The reason for that is, like we said, the use of more antennas. So on average, the Gigabit LTE device is using 3 antennas to receive the data, whereas the Cat6 device, of course, is capped at using 2 antennas because Cat6 devices are typically not 4x4 MIMO capable. Okay, so this is, like I said, for this kind of scenario where 40% of the users are, Cat4 devices, and only 7% of the users have Gigabit LTE devices. But what if I were to reverse this? So watch what happens if I go to a different mixture where 40% of the users have Gigabit LTE devices and only 7% of the users have Cat4 devices. Watch what's going to happen to both throughputs here. Okay. So look at that. The speeds for both users went up, for the Gigabit LTE device as well as for the user who has an older Cat6 device. And this actually makes sense if you think about it, right? So we showed here on the graphs that the Gigabit LTE devices are more efficient. They use fewer of the network resources to get the speeds that are needed to service whatever traffic they're generating. So actually, the more of these devices there are on the network, the higher the capacity of the network overall, which benefits even people with the older devices. And actually, let's look at the video scenario for a second. Okay, so what this is showing is that both of these users are actually getting the same bitrate video. So this is 29 megabits per second. This is actually a very high quality video. For example, for emerging use cases like streaming 360-degree video, which is something that you can do with the Gear VR on the Galaxy S8, for example. Look at this. So they're both getting the same quality video. However, look, the Gigabit LTE device is using 1/3 of the network resources. So the network is able to deliver the same quality video, but actually use way fewer spectrum resources to do it. And I think in the age of unlimited data plans, this makes perfect sense why the operators are so keen on upgrading to Gigabit LTE. Because of the higher efficiency, they can actually deliver more video traffic on the existing spectrum resources that they have. Okay, so that was for video. Let's go back to FTP. Like I said, this was for the median users. Let's look at people who are in good signal conditions. So let's look at the 90th percentile. Look at that. The median Gigabit LTE user, sorry, the Gigabit LTE user is getting over 200 megabits per second, whereas the Cat6 user is getting 115. And I think, based on the speed tests that people post every now and then on Reddit, for example, a Cat6 device getting 116 megabits per second is not possible. But look what the Gigabit LTE device can get. And actually, this estimate is a little bit conservative. So as you may know, Telstra in Australia was the first to launch a Gigabit LTE network and a Gigabit LTE device that has the X16 modem inside. And actually, we've had multiple analysts, for example, Anshul Sag from Moore Insights and Strategy, as well as Milan from Cellular Insights, where they got their hands on the devices in Australia and they did some testing. And they saw real-world speeds, 350, 400, and all the way up to 500 megabits per second. So this is really phenomenal because at these speeds, this is actually faster than the random read speed of flash memory, right? So you can think of having all of your devices stored in the cloud, and in essence, you can open them from the network almost as fast as you can open them from local storage. The difference, of course, being the latency, but still, from a read speed perspective, the download speeds with Gigabit LTE over the network are actually matching those of flash memory, and this is it's a big deal. Obviously, it's something that we've always dreamed of, breaking down this barrier between the device and the cloud, and Gigabit LTE really makes it happen. So this is basically what I want to show. Like I said, this is actually a very detailed simulation. You can drill down into any individual users. You can narrow down by traffic type. So let's look at the bursty traffic, and we can compare the people who are in the same signal quality. Let's see, let's select Gigabit LTE and Cat6 again, and you can see the burst rates, for example. Now we're talking about over 500 megabits per second. So this is really why the networks really want Gigabit LTE and why it benefits everyone, because they can serve bursty traffic so quickly, which then frees up the network resources for other people that are trying to use it. Compared to Cat6, of course, see the burst rate is much smaller. So, like I said, Gigabit LTE, very exciting. We're glad to finally see a device coming to the US in the Galaxy S8 and the S8 Plus. And of course, the networks, including T-Mobile, Sprint, and AT&T, who have all announced that they're going to support Gigabit LTE this year. And one more thing that I wanted to touch on, which is LTE-U. So, the Galaxy S8 and the S8 Plus are actually the first devices in the world to use LTE-U technology. So this is a very exciting day. We at Qualcomm have been working on LTE-U since 2013 when we first introduced the idea. And today the first device is coming out. T-Mobile has announced that they're rolling out LTE-U in the network today. And really the best way to think of LTE-U is it's just another LTE carrier, and it combines with their licensed LTE carriers through carrier aggregation. Okay, I see a question in the chat. Spectral efficiency gains with Cat16 UE available even when network is still Cat9, okay, or eNode B capability not so important. So the spectral efficiency gains will apply regardless of how much spectrum is being used. So whenever there's an LTE carrier that's available that where 4x4 MIMO is deployed or where 256 QAM is turned on, you will see higher efficiency gains on those LTE carriers. So yes, even if the network doesn't have the full 60 megahertz of spectrum deployed in that particular geography, as long as those other features, 4x4 MIMO and 256 QAM, are turned on, you will see the higher spectral efficiency and higher capacity for the network. So back to LTE-U, like I said, LTE-U is essentially just carrier aggregation, right? So it's carrier aggregation, but in those geographies where the network operator does not have enough licensed spectrum to get to Gigabit LTE, or in a crowded place, for example, like an airport or a mall or a college campus or a busy downtown intersection, they can actually deploy LTE-U surgically to increase the capacity of the network. And the reality is that people with devices like the Galaxy S8 and the S8 Plus, which support LTE-U, they're essentially going to get their own separate lane on the LTE-U carriers, and their speeds can be much, much faster. So it's kind of the incentive for why you want to buy a new handset with LTE-U capability. As the networks are rolling out this feature, it really is a great capacity boost for the network. We expect the speeds to be much faster than they would otherwise be in crowded areas. So overall, just a great day for LTE technology. It's fantastic to see all of these things that we've been talking about for so long finally coming to fruition. And we look forward to all of the speedtest.net screen caps from the apps once you actually get your hands on the Galaxy S8 and you are out there testing it. So we have another question in the chat. Is this a Qualcomm exclusive technology? And then there's an additional part there. So we make the Gigabit LTE modem available in two forms. So either integrated inside the Snapdragon processor itself, which is the case in the Galaxy S8 and the S8 Plus. But we also make a standalone modem that can be attached to a third-party application processor. So for an OEM that uses their own application processor, they can use our modem alongside it. Now, as to whether an OEM will use the full feature set of the modem, that's entirely up to the OEM to decide whether they will implement the necessary antennas to support things like Gigabit LTE, like LTE-U, or license-assisted access technology. It's kind of up to the OEM to decide. From kind of a competitor perspective, I see There's a question about Intel. So Qualcomm was the first to to make available a Gigabit LTE modem. We were the first to commercialize it. Definitely the first smartphones with it now, with the Galaxy S8, S8 Plus, as well as the Sony Xperia XZ Premium, as well as the Motorola device that was shown off at a Sprint event recently. And our competitors are behind. So, for example, you mentioned Intel specifically. They announced their Gigabit LTE modem just at this past MWC, but it's not going to be commercial until next year. So any phone that uses an Intel modem this year will not have Gigabit LTE capability. Okay, another question here. Will LTE-U be broadcast from the macro tower, small cells, or both? Okay, excellent question. So LTE-U is strictly a small cell technology. There is no such thing as LTE-U being broadcast from the cell towers. And the reason for this is since LTE-U is an unlicensed spectrum technology, it has to abide by exactly the same rules for unlicensed spectrum that also govern Wi-Fi. So in whatever the output power limitations are that Wi-Fi routers have to abide by, small cells with LTE-U also have to abide by the same, at least in the unlicensed spectrum portion, or the LTE carriers that are in unlicensed spectrum. And so LTE-U is really meant to be targeted, like I said, surgically, essentially, at, I would say, heavily congested areas where LTE networks usually crawl to a halt. Like, one of my pet peeves is being in the airport, and because there's so many people there, sometimes the LTE networks will ground to a halt just because there isn't enough capacity. Well, that's exactly the type of thing that LTE-U will solve. So the operator can add LTE-U to the airport, for example, or to the mall, or any other kind of public space using LTE-U small cells, and the LTE-U signal will not propagate beyond a few tens of meters or a few hundred meters. So yeah, it's definitely a small cell technology. And I guess that's the second question there. Yeah, so LTE-U has the same propagation characteristics as 5 gigahertz Wi-Fi. They're limited by the same output power, but LTE is slightly more efficient. So actually, we get better range with LTE in the unlicensed 5 gigahertz band than we do with Wi-Fi. And actually, we've shown that repeatedly in our tests of LTE-U and LAA. And so you can expect faster speeds at a longer range with LTE-U than you would with 5 gigahertz Wi-Fi. Next question, how much better is the X16 modem compared to Shannon modem and the Exynos? I will defer those kinds of questions to the OEM who is implementing both modems to answer. What I would say is that at Qualcomm, we have been at the forefront of really bringing Gigabit LTE technology to the market. And if you were to think about it, the Snapdragon 835 with the X16 modem is actually our third iteration on technologies like 4x4 MIMO. And those technologies are not trivial to implement. They're actually very, very hard. And so we've had several generations of learning, whereas some other providers are just bringing their first 4x4 MIMO products to market. And we'll see how they do in the real world. Okay, any other questions on the chat before I end the session? Okay. All right, well, thank you everybody for joining. As always, you can find me on Twitter. My handle is @SharifHanna, first name, last name, and I'm also active on Reddit on the Sprint and T-Mobile subreddits. And hope to see you out there. Enjoy the Galaxy S8 and S8 Plus. I look forward to get my own and put it to the test out there and enjoy all of the great speeds that have been promised to us for so long, and they're finally coming to fruition. So thank you everybody for your time.